Trigonometry, the study of triangles and the relationships between their sides and angles. In this video, we will look at how to find an unknown angle in a non-right angle triangle using the sine rule. Now, example number 1, find the measure of the angle A correct to 1 decimal place. So first of all, we'll do our checklist. So is it a right angle triangle? No, it's not. Is it a non-right angle triangle? Yes, it is. So the first thing we'll check is, do we have two pairs of opposites so we can use the sine rule? So looking here, we can see that the 12 is opposite the angle A and the 11 is opposite the angle 65. So we do have two pairs of opposites, which means the sine rule is perfect. So go to your log tables and find the sine rule. So here in my log tables then, on page 16, I have the sine rule, and it tells me that the side over the sine of the angle equals the side over the sine of the angle. So then, using my two pairs of opposites, I build my solution to make those two ratios. So 12 over the sine of A equals 11 over the sine of 65 degrees. Now, because I have one ratio equal to another ratio, I can cross multiply. So the only thing I would ask is that you leave your unknown on the left hand side for ease. So let's multiply 11 by sine A first on the left equals 12 times the sine of 65 degrees. Then we're going to use our balancing method to finish our solution. Now we're trying to solve for A, and if you look here on the left, there's quite a lot going on with A, so let's investigate that. If I wanted to build the left hand side there, I would start with the angle A, then take the sine of the angle A and then multiply by 11. So what I need to do then to solve for A is I need to reverse that. So I'll be going from the 11 times sine A back to sine A back to A, and we'll be doing it in that order. So the first thing I need to do is see that the sine A is multiplied by 11, so to reverse that I need to divide by 11. So dividing both sides by 11, on the left hand side my 11s will cancel, so I'm left with the sine of A equals, and on the right hand side I have 12 sine 65 divided by 11. Now at this point, what most people do is they just simplify what they have there on the right hand side before moving on, because this is a long enough sum. So it's a ratio of 12 sine 65, close bracket, down arrow, divided by 11. Okay, and that equals 0.988699404. Now, because we're not at the end of our sum, I'm not going to round off too much because I'm not at the end of the sum. I want to ensure accuracy. So in trig, I generally take 4 decimal places. So if you look here, we have 9886. After the 6, I have a 9, so I'm going to round that up. So I'm going to take 9887 as my answer for my sum. But even better than that, I could actually capture the whole answer because my calculator keeps it for me. This here answer will be kept in the answer button. So if I leave it like that, for when I come back to do my next sum and I press answer, it will bring up this answer for me. So now I have that the sine of A equals 0.9887. So lastly then, my A, I'm taking the sine of A. So to reverse sine, I need to use sine inverse on both sides. So sine inverse and sine will cancel, leaving me the A that I'm looking for. And on the right hand side then, I've taken sine inverse of 0.9887. So we're going to put this straight into our calculator now. So if you've left this just as it is, this will be in the answer key. So just go ahead now and do sine inverse. So shift, sine inverse, and if you press answer, it will use that full ratio for the full decimal point that you had on the screen. Equals. Okay? Or you can type in 0.9887. That's totally fine, but just for ease, use your answer button. It's very useful. Now this question here looked for the angle A correct to 1 decimal place. So after my 1 decimal place, I have a 7, so I'll be rounding up. So my answer is 81.4 degrees. Remember, you're looking for an angle. So A equals 81.4 degrees. Now, example number 2, find the measure of the angle B correct to 1 decimal place. So let's do our checklist. Is it right angled? No. Is it a non-right angled triangle? Yes. So let's check if we have 2 pairs of opposites for the sine rule. So we do. We have 10 is opposite the angle 67 degrees and 7.2 is opposite the angle B. So that means that the sine rule is perfect for solving for B here. So go to your log tables and find the sine rule. So the sine rule is on page 16 of the logs, and it tells us that a side over the sine of an angle equals a side over the sine of an angle. So we use that to build our solution. So we have 7.2 over the sine of B equals 10 over the sine of 67 degrees. We have one ratio equal to another ratio, so we can cross multiply. So that's 10 multiplied by the sine of B equals 7.2 multiplied by the sine of 67. Then we're going to use our balancing method to do the rest of the solution. Now, investigating what's happening to B there on the left hand side, we have the angle B, then the sine of the angle B, then multiply that by 10. So to reverse that, we will be dividing by 10 and then taking the sine inverse to get back to B. So first of all, we will be dividing both sides by 10. So that will cancel my 10s on the left, and I'll be left with the sine of B equals 7.2 sine 67 divided by 10 on the right. So at this point, we'll just simplify. So get your calculator and simplify that. So ratio 7.2 sine 67 and bracket arrowed down divided by 10 equals, okay, so 0.6627, again, it's after my 4 decimal places, I have a 6, so I'm going to round up. Okay, and I'm also going to leave my answer there, so it is in my answer button. So I have the sine of B equals 0.6628. Now I have the sine of B on the left, but I really just want B. So to cancel the sine, I need sine inverse, and I need to take sine inverse on both sides. So on my left, I'm left with the B that I'm looking for, and on the right, I need to take the sine inverse of 0.6628. So on your calculator, then just press sine inverse, so that's shift, sine inverse, and sine inverse of my previous answer, please, equals 41.51. Correct to 1 decimal place as it is in our question. So after 5, I have 1, which means I'll round down. So my answer will be 41.5 degrees for this angle. Okay. Now, example number 3. Find the measure of the angle ACB correct to 2 decimal places. So this is a little different because this time the vertices have been labelled A, B and C. And we've been asked for the measure of the angle ACB, which is the angle at the vertex C. So here it is, the measure of the angle ACB. The easiest thing to do is to remember that it's always at the vertex in the middle. Okay, so at the vertex C. Now the angle at the vertex C can also be called the angle C with a capital letter. So I'm going to choose that for this question. So I'm going to let the angle ACB equal just the angle C for ease of use. Okay, so we have this in our exam papers, and first thing, let's check, what am I looking at? Is it a right angled triangle? No. Is it non-right angled? Yes. Do I have 2 pairs of opposites? So let's check. I can see that the angle C is opposite the 12.2 and the angle 48 is opposite the 10.1. So this is perfect for the sine rule. So on page 16, we have the sine rule that the side over the sine of an angle equals the side over the sine of an angle. So using the sine rule to build our solution, we have that 12.2 over the sine of c equals 10.1 over the sine of 48. One ratio equal to another ratio means we can cross multiply. So we have 10.1 multiplied by the sine of c equals 12.2 multiplied by the sine of 48. So first of all, the sine of c is multiplied by 10.1, so the reverse of multiplying is divide. So divide both sides by 10.1. So they cancel each other off, and on the left hand side I have the sine of c equals 12.2 sine 48 all over 10.1. So let's stop here to simplify. So we have the ratio of 12.2 times the sine of 48, close bracket, down arrow, divided by 10.1. And so my answer is, so 0.8976, and after my 6 I have a 6, so I will round up to 8977. So I have the sine of c, but I only want c. So to reverse sine, I use sine inverse on both sides, and they will cancel each other out to leave me with c on the left hand side that I'm looking for, and on the right hand side sine inverse of 0.8977. So I take the sine inverse, so shift sine of my answer equals 63.85, and it's correct to 2 decimal places the question. So after my 85 I have a 2, which means I'll round down. So my answer is 63.85 degrees. Okay,